Before we move on to another aspect of statistics, let us look back at what we have been presented and learned so far. As we know, statistics, including biostatistics, is the science of making inferences about specific random phenomena on the basis of relatively limited sample material or data. We have been able to describe a data set by looking at its spread. Okay, so when we solved for variances, when we solved for the standard deviation, when we solved for the range, we were looking at the spread. And also we were looking at specific data points of interests, like the sample mean or the median and the mode. Grouping data points using the frequency distribution table has also been done to better interpret and present the data using graphs. Okay, so by now, I think all of us know how to create a frequency distribution table from a raw data set. And from this frequency distribution table, make a graph such as this histogram that is a representation of the data, a visual representation that our audience who are interested with our studies can appreciate. When working with data like these birth weights, okay, we are essentially working on events and their outcomes. Thus, the concept of probability has also been tackled. So we talked about the concept of probability as well. When we combine data presentation and probability, we come up with what we call as probability distributions. We have distinguished two types of these so far. We have discrete and continuous. Despite the differences in the nature of the variable being dealt with in these two types of distributions, we recognize their similarities. Okay, so we had probability distributions. So far, we recognize two of them. Let's just represent them this way. We had discrete probability distributions. And then we also talked about continuous probability distributions. Okay? So although they are different in terms of the nature of the variable, there are similarities. Probability distributions, for example, are graphed with two axes in mind. Okay, so there are always two axes. Okay. So the values of the outcomes are in the horizontal axis. So you have here your outcomes. And the probabilities of obtaining these outcomes are graphed in the vertical axis. So in a way, if we talk about the normal distribution, the outcome whose value is average, we call the mean, is also the mode of our distribution, the one which has the highest probability. The highest point on the distribution, as I just talked about, represents the mode. And in normal distributions, the mode, which is this one, is the same as the mean and the median. So both the mean, all the mean, median, and mode are at this point for normal distributions. So continuous probability distributions, however, have one important distinction from discrete distributions. Okay? Although they're similar in how we graph them, the axes, there are differences. We cannot assign, for example, a specific probability of a single value of an outcome. So in this continuous distribution here, you cannot assign the probability of just this particular outcome, n. Okay? So that's impossible. So put in another way, we cannot predict the occurrence of a specific outcome point. Instead, what can we do? We always consider a range of values of the outcomes and compute their probability of occurrence. So we might not be able to predict the probability of this particular outcome from happening, but we can predict the probability of outcomes greater than this particular outcome from happening. We can always predict the probabilities or compute the probabilities of areas under this normal curve. So in this module, we have to keep this in mind. Okay, we will explore the ways by which we can estimate. So the title of this module is estimation. What do we estimate? We estimate what we call as parameters of a population using a limited amount of data in what we call as a sample. So you predict the parameters using your sample. We do this by looking back every now and then at the characteristics of a probability distribution. So never forget the characteristics, especially of the normal continuous probability distribution, and of course, the standard normal distribution. So in the next lectures, we will be talking about estimation.